All right, hey guys. Mr. F, you got a quiz Monday. We said Monday, right? So hopefully you're watching this Saturday night, Sunday night, trying to get yourself ready to go. But let's run through this. This is their quiz review, but this is quiz review number 2. So make sure you're looking at the right review sheet. If you wanted help with quiz review number 1, I posted an answer key for that, but there's no video. There's just the answer key that you can check your answers against. But I figured for this one I'd give you guys video, so here goes. Let's take a look. It says for angles 1 and 9, you have to name the transversal and then classify the angles. And when you classify, you're going to classify them as alternate interior, alternate exterior, etc. Which means that list right there is not everything. So let's make this a list of everything. Oops, I did that wrong. Just color that in white. Nobody be the wiser. So what do we got? Alternate interiors, alternate exteriors, same side, same side. So that's pretty much everything actually, but we're missing the original 2 special angle pairs that we learned about, which of course were vertical angles and linear pairs. And so those could potentially come up. Anyway, for 1 and 9, if you take a look at the diagram, you should hopefully be able to tell that the transversal is that one line that hits both of those angles. So that for sure is line R. And then what kind of angles are these? Well, you should notice they lie on the same side of the transversal, but one is on the exterior of M and K, 9 is on the interior of M and K. So they're not same side interiors or same side exteriors. And so hopefully roundabout then it hits you that 1 is in the upper left. And then if you come down here, 9 is in the upper left. And when they're in the same position like that, they're corresponding angles. And then nobody asked you to do this, but just for practice, you might want to also write that because they're corresponding. Well, actually, let's not write this. I was going to say they're congruent, but clearly, as you look at M and K, they're not parallel. And remember, corresponding angles are only congruent when the lines are parallel. So I guess that's why we're not saying whether the angles are congruent or supplementary. Okay, so what you want to do now is kind of start all over, get rid of everything that's on the diagram, and just start again. This time we're looking at 11 and 16. And so if 11 is here and 16 is here, then now you can see that the transversal, the line that hits them both, is line K. And 11 is below the transversal, 16 is also below the transversal, and 11 is outside of R and T, 16 is also outside of R and T, so those are definitely same side exterior angles. So that's it for those. Now we got 8 and 13, so that's 8, that's 13. So the one transversal cutting down through is line T. And what kind of angles are these? Well, again, I've got one to the right, one to the left. So that should feel like alternate. And they're both on the interior. So these are alternate interior angles. And again, just for anyone who hasn't heard me say it, when we talk about alternate, some people want to say it's alternating or alternate or whatever, but you really pronounce this word as alter, knit, like you're knitting a sweater. So not that it matters how you pronounce stuff, but just in class, if you're going to talk to me about it, say alternate. Don't say alternating. That's not right at all. All right, moving on. So what's our next pair? 6 and 3. So 6 is up there. Oops, get rid of that. 3 is over there. So the transversal that they share is line M. And their classification is 1 below, 1 above. So those are alternate. They're on the outside. So those are alternate exterior angles, then we got 14 and 10. So that's 14. Whoops. 10's over there. So this again has line K as its transversal. And the classification would be, let's see, from this point of intersection, I'm in the upper right. From this point of intersection, I'm in the upper right. So 10 and 14 must be corresponding angles. And then our last angle pair is 7 and 13. So here's 7, here's 13. The transversal is T. And the classification is that these are both to the left of transversal T, so they're same side. And they both lie between M and K, so they're interior. So they're same side interior angles. Alright, now I guess we added in the vertical angles and the linear pair thing. Well, there weren't any examples of that, but there's a question down here that asks you to name a linear pair and vertical angles. So they want you to name somebody who's a linear pair with 13. So there's 13. So there's two different angles that form a linear pair with 13. You could do 13 and 14. They form a nice straight line. Or you could do 13 and 15. It only wants one or the other though, so just pick one. I'm going to go with 14. If you said 15, that's fine too. And finally, they want vertical angles with 12. So if you go look at 12, the only angle that's a vertical angle with 12 is the angle directly opposite from it when these two lines intersect. So the only guy that's vertical angles with 12 is angle 9. No other answer there would work. Alright, 7 minutes to do that one problem. We should probably try to go faster. Alright, taking a look at number 3. Actually, taking a look back to number 1, remember that here we did not know if the lines were parallel or not. So we could not say that the corresponding angles were congruent or that the same side interior angles were supplementary. None of those rules are active unless you know that the lines are parallel. Now looking at number 3, I do know that the lines are parallel. Sometimes to show that they're parallel, we'll put arrows on them, like that. So be on the lookout for that, I guess. But they now want to know, well, we got to solve for x. So they're talking to me about 3. 3's right there. They're talking to me about 6. 6 is right there. So you have to think about what kind of angles you have, because those angles might be congruent, but they also might be supplementary. And depending on how the angles relate to each other, you'd write a different equation to solve for x. But I can see looking at these angles that they are alternate interiors, and that makes them congruent. And because they are congruent, I'd want to write my equation as 11x plus 10 is just directly equal to 5x plus 70. So I've got this equation now, and to solve it, I've got 11 x's over here on the left, only 5 over here on the right. So your smart move is to subtract 5x from both sides. And when you do that, these 11 x's take away 5 will turn into 6x. You've got the plus 10 still, bring that down. Over here, the 5x minus 5x cancels, and you just still have your 70 now. So now, to start to get x alone, you'd want to get rid of the 10 first. And since it's plus 10, you'll subtract 10. And that'll make these cancel. So you now have 6x equals 60, and then dividing by 6 gives you 10. And now that you have x, you can go in and plug in x to find angle 3, or you could plug in x to find angle 6. But honestly, you only need one angle, because once you have one, you can use vertical angles to say they're the same. You could use linear pairs to figure out 4. Once you have 4, you could use 4 to find 2. 2 will give you 5. 5 will give you 6. So you can find everybody just by finding one angle. So I say, I don't know, pick either one. I don't care. Let's start by finding the measure of angle 3. But it says angle 3 is 11x plus 10. But I now know that x is 10. So instead of x, I can substitute in my 10, do the math, figure out the answer. So I'm looking at 11 times 10, that's 110, plus an extra 10 is 120. So we know that angle 3 is 120 degrees. But we also know that in a diagram like this, if one obtuse angle is 120, then all of the obtuse angles are 120. We know that 1 and 3 and 6 and 5 are all going to be 120. We also know that these acute angles, 2 and 4, well, they're linear pairs with 1 and 3. So 2 and 4 have to be the supplements of the 120. So 180 minus 120 tells us that all these acute angles are 60 degrees. So we're like done with this whole problem now, because we know that 3 is 120, but we know 1 is going to be 120 as well. We know that 2 is going to be 60 because it's linear pairs with 3. We know that 4 is going to be 60 because 4 is congruent to 2. We know that 5 is congruent to 3 because they're corresponding. So if 3 is 120, then 5 is 120. And then 6 is the same as 5 because they're vertical angles. So there's that whole problem. Now part B. Part B is just telling us that there's a different value for 5. So just forget all about part A and now do the problem using this new information where 5 is 122. But the idea is still the same. If this obtuse angle is 122, then this one has to also be 122, and this one has to be 122, and this one's 122. And we could prove all that. We know that 5 and 6 are the same because they're vertical. 5 and 3 are the same because they're corresponding. 5 and 1 are the same because they're alternate exteriors. So we already know all of those angles are the same. So 1, 122. 2, well 2 is going to be acute, but 3 is 122. 4 is something else, but 6 is 122. So 3 of those angles are all 122. And now the other 2 and 4, are just going to be whatever 180 minus 122 is, because we know they're supplementary. So that's 58. And 4 will also be 58. And that's it. No big whoop. Let's try 4. Okay. So again for 4, we do know that the lines are parallel. We already know that for sure. You can mark them with arrows if you want to. It says use the angle relationships to solve for x and y. So you might look at this and say, hey, 2x plus 8 has to equal 4y because those are vertical angles. But don't do that, because if you write an equation where 2x plus 8 equals 4y, then you're not able to solve it because there's two different variables. And we only want to focus on equations with one variable. So I would focus on x and notice there's a second expression up here that also involves x. So I can definitely work with that. Now what kind of angles are these? Those are same side exteriors. And same side exteriors are supplementary instead of congruent. So because they're supplementary, I know I want to write an equation where the one angle plus the other angle equals 180. So don't just set these equal to each other. Set them so that the 2x plus 8 plus the 3x plus 7 will equal 180. Now, because I have a 2x over here on the left of my equation and a 3, we're going to combine those. You just add them together to get 5. And we can do the same with these constants. There's this plus 8 and this plus 7. You're not going to subtract them from both sides. You're just going to add them together first. We want to simplify the left-hand side. This right-hand side we'll leave alone. That side's just going to still be 180. But over here, my 2x and my 3x, they give me 5x. My plus 8 and my plus 7 gives me plus 15. Now you're looking at an equation you might be more familiar with, because now to solve for x, you know that you'll subtract 15. Those will cancel. You'll get 5x equals 165. Then you'll divide by 5. And you'll find that x is worth 31. 33? Hold up. Be 15 left over, right? So 33. Alright, I don't know why that took me so long. Okay, but now you gotta solve for y. So how do you get y? My plan would be, actually let's go back to that thing I said was wrong a minute ago. The 2x plus 8 and the 4y, those have to equal each other because they're vertical angles. So the trick is then, take the 2x plus 8, substitute in the 33. That'll give you 66 plus 8, that'll be 74. So now that you know that this angle is 74, you know that this angle will be also 74, which means you can now just solve that. We can say that the 4y has to equal 74. So dividing by 4, I think this is the one that comes out to be a decimal, which is fine. If you divide by 4, you get 1 and then 34. So 18 with 2 left over. So you're getting 18.5. And there's not a lot of decimals on here, but there can be decimals, so don't freak out if you see one. 18.5 is the right answer. Okay, keeping on. Blanc. Number 5. So finally now we're looking at some problems where we don't know if these lines are parallel or not, right? So they're saying, hey, based on just 2 and 8 being congruent, can you make any assumptions about any of these lines? And looking at 2 and 8, we can see that n would be the transversal passing through them, which means maybe, just maybe, P and Q are parallel. But one thing's for certain, I don't give a damn about line M down here. You could ignore that whole mess. So what's happening? Angle 2 and angle 8 are alternate exteriors. And it says they are congruent? Oh, that definitely makes us parallel then. If yes, state your parallel lines, P and Q. P is parallel to Q. It says if no, why not? But nobody wants that. Also because it's not a no. A better thing that you might want to spend a minute on is why? Like, why are the lines parallel? And the answer to why the lines are parallel is P is parallel to Q because the alternate exterior angles are congruent. But that's the reason. You know the lines are parallel because the alternate exterior angles turned out to be congruent. Moving on. All the other questions are going to feel the same way, by the way. But they're asking us about 6 and 13 this time. There's 6. There's 13. Those are same side interior angles. And if the lines were parallel, those same side interior angles would be supplementary. Oh, it says right here that they are supplementary. So since they're supplementary, we do know that we've got some parallel lines. Q is the transversal. So it's N and M that are getting intersected. So it's N and M that we can say are parallel. And that's it. You don't have to do the if no, why not thing. So let's try part C. They want us looking at 12 and 14 this time. So 12 is there, 14 is there. It looks like you've got M as a transversal. And it looks like we're working on P and Q. We would normally want our alternate interior angles to be congruent. It says here they're supplementary. So do we have the information to prove that these lines are parallel? No, we don't. Which means don't fill in that box. But they're saying, hey, why don't you have enough info? And you'll say, the angles we have here are alternate interiors. So you'll say alternate interiors are congruent when the lines are parallel. And that's it. For P and Q to be parallel, you would need 12 and 14 to be congruent. And it doesn't say they're congruent, it says they're supplementary. So moving on. 7 and 15. There's 7. There's 15. So those are corresponding angles. And if the lines are parallel, then those corresponding angles would be congruent. Oh, they are congruent. So you'll say yes. The lines that are parallel based on this, well, Q would be the transversal. You'd ignore P, and it's M and N that look like they're parallel. And that's that. And so now for 6, they're doing basically the same thing. They want you to conclude that yes, the lines are parallel, they are not parallel, or that you really don't have enough information to say. So looking at E, they're talking about 14, 16. That's these vertical angles. Vertical angles are always congruent. So these vertical angles don't help me say anything about P and Q, which of course you probably knew, because looking at P doesn't actually form either of these angles. Both of these angles are formed by just M and Q. So there's nothing we can say about P and Q. Nothing at all. Okay, I just had to pause the video for a minute so I could make these colorful thingies. I just didn't feel like writing all the answers. Now I can grab this and just drag it down. So we know that you can't say anything about P and Q based on 14 and 16 because 14 and 16 are vertical angles. They don't give us any information about parallel lines. So let's try the next one, which says 12 and 3 add up to 180. So that means they're supplementary. So what are 12 and 3? This guy and this guy? All right, great. So if 12 and 3 are supplementary, well, we want them to be supplementary because those are same side interiors. So P is the transversal, but the lines that we would prove here are M and N. And we can say that yes, they are parallel. Excuse me. Now if you wanted to go the extra mile, you could say they are parallel because the same side interior angles are supplementary. And that's sort of the full explanation about why those lines are parallel. Next. So this time it's 6 and 16, which is those guys. 6 and 16 are alternate interior angles, and those would be congruent when the lines are parallel. So yeah, we can prove that M and N are parallel based on this information. Okay, again, I don't know if you want to do this, but we'll do it anyway. Hey, why are they parallel? You'll say because of. Well, what are these angles? Alternate interior angles? So it would be because of the converse of the alternate interior angles theorem. Okay. So now they're talking about 10 and 14. And they're saying they're congruent. So 10's over there, 14's there. Good, those are corresponding angles. So the fact that they're congruent means that yes, we are parallel. And the angle pair that they gave us, 10 and 14, is corresponding. So you can say these guys are parallel because why? So they are parallel because of the converse of the corresponding angles postulate. And finally, part I. It's talking to me about 4, that's that guy, and 12, that's that guy. So 4 and 12 are just corresponding angles again. They want us to draw a conclusion about M and N. Well, if my corresponding angles are congruent, then we would be parallel. But we're not, because it says 4 is 80, it says 12 is 100. Those are not the same. So we should here be concluding that they are not parallel. And your justification would be because the corresponding angles are not congruent. Okay, keep moving. I think I'm actually going to stop here. I'll post more tomorrow. Just feeling tired. Talk to you later. Bye.